So we have some construction rules for the root locus. What is the rule number 1? The root locus is always symmetrical about the real axis and the number of branches is equal to the order of the characteristic polynomial. What does this mean? Number of poles of the open loop transfer function. What is rule number 2? All branches of the root locus start at open loop poles when k is equal to 0 and either at open loop zeros or infinity when k is equal to infinity. The number of branches terminating at infinity equals to the difference between the number of poles and the number of zeros of g of s, h of s. Rule number 3. A point on the real axis lies on the root locus if sum of poles and zeros on the real axis to the right of the point is an odd number. The n minus m branches, root locus branches that proceed to infinity do so along asymptotes phi a is equal to plus minus 2q plus 1 into 180 degrees divided by n minus m, where n is the number of poles and m is equal to number of zeros. So q can be 0, 1, 2, etc. If the number of poles is 3 and the number of zeros is 1, then n minus m is 2. Rule number 5. The centroid, the point of intersection of the asymptotes with the real axis, is given by sigma a is equal to sum of real parts of the poles minus sum of real parts of the zeros divided by number of poles minus number of zeros. Rule 6. The breakaway points at which multiple roots of the characteristic equation occur of the root locus are a solution of dk by ds is equal to 0. Rule number 7. The angle of departure from an open loop pole is given by phi p is equal to plus minus 180 degrees into 2q plus 1 into phi. Rule 8. The intersection of the root locus with the imaginary axis can be determined using Routh criteria. Rule number 9. The open loop gain the transfer function in an open loop 0 at any point s0 on the root locus is given by k into pi by s0 plus pi by pi into s0 plus z. K is the product of the phasor lengths from s0 to the open loop poles by product of phasor lengths from s0 to open loop zeros.